So I want you to imagine an 80-year-old billionaire.
Okay.
They have, infinite resources, absolute power, access to literally the most exclusive healthcare on the planet. Private jets, yachts, you name it.
Right, the absolute peak of society.
Exactly. And yet, if you offered them all of that money, all of that power, to trade bodies with just a completely broke, average, but physically healthy 30-year-old.
Oh, they would make that trade in a heartbeat.
Every single time.
Yeah.
Without hesitation.
Yeah, absolutely.
Because we have all implicitly accepted this terrifying universal lie. And that is that the physical agonizing decay of our bodies over time is just, well, an inevitable law of nature. But today on this deep dive, we are completely tearing up that rulebook.
We really are. We're jumping into a framework that fundamentally reclassifies human aging. I mean, for the entirety of human history, the medical community, and honestly just society at large, has looked at aging as this one-way street of entropy.
Right. You just get older, things break down.
Exactly. Things break down, you try to manage the symptoms of that breakdown, and then eventually you die. That's the script.
Yeah.
But our source material today is focused heavily on the work of Dr. David Sinclair, right? He's a geneticist and a longevity researcher at Harvard, and he has spent the last 3 decades in his lab proving something that honestly sounds like pure science fiction.
It really does.
He argues that aging is not a natural inevitability. It is a highly specific and, more importantly, a treatable disease.
I want to let that sink in for the listener for a second. We treat infections, right?
Right.
We treat broken bones, we treat cancer. But when you start looking at the systemic decline of your cells, the wrinkles, the loss of energy, the failing organs.
The things we just accept as normal.
Exactly. When you look at that as a curable pathology, rather than just the way things are,
Right.
the implications are just staggering.
They're world-changing.
Because we aren't talking about adding a few miserable, frail years to the end of your life, like just keeping you alive in a hospital bed hooked up to machines.
No, nobody wants that. The goal isn't just lifespan, it's health span.
Right. We are talking about adding decades of vibrant, peak physical life to your years. Imagine turning 80, blowing out the candles, and then, I don't know, going for a 10-mile run with the exact same biological hardware you had at 25.
That is the ultimate goal here. And, the crazy part is it's grounded in decades of rigorous, peer-reviewed laboratory research. We've got successful animal trials that have literally reversed the biological clock.
Which we're going to get into, and it is mind-blowing.
Oh, it really is.
Right.
And there are human clinical trials that are actively underway right now. Yeah. But to get there, to really grasp this, it requires a complete paradigm shift from you, the listener.
Yeah, we have to unlearn almost everything.
Exactly. We have to unlearn the core assumptions we've held about why our bodies fall apart in the first place.
And a lot of that unlearning, according to Sinclair's work, starts with understanding how deeply ingrained our acceptance of death really is, like from an incredibly young age.
Right. He actually shares this deeply personal, almost, well, it's a heartbreaking anecdote about how this realization first hit him.
Oh, yeah, the story about his grandmother.
Yeah. So when he was just 4 or 5 years old, his grandmother, Vera, was reading to him. She was reading from that classic A.A. Milne book, Now We Are Six.
Oh, Winnie the Pooh.
Exactly. And there's this very famous innocent poem at the back of the book that counts up through the ages of childhood. And it ends with the lines, "But now I am 6. I'm as clever, so I think I'll be 6 now forever and ever."
It's just this beautiful crystallization of childhood permanence.
Right. It's a feeling every single child inherently believes. Like, the world is static, my parents will always be here, and I will always be safe in it.
But his grandma, she didn't just agree with him.
No, she didn't. See, she had survived the horrors of World War II in Hungary. She had seen the absolute worst of what time and humanity can do to people. So when he asked her, if he could stay a child forever and if she would always be around to protect him, she didn't sugarcoat it at all. She gave him the brutal, unvarnished truth.
What did she say?
She looks at this tiny kid and said, "No. Everything dies. I'm going to be gone, your parents will be gone, your pet cat will be gone, and one day you will be dead too."
I mean, you could just imagine the psychological earthquake that causes in a young mind.
Oh, for sure. Suddenly, that illusion of permanence is totally shattered.
But what's fascinating is that rather than falling into nihilism, or just, accepting it as this grim reality of the universe like most of us do?
It ignited a profound rebellion in him.
Yeah.
He basically refused to accept that just because something is widespread and natural, it somehow means it's acceptable. And that moment became the catalyst for his entire lifelong scientific obsession with the mechanics of mortality.
So if we're going to try to cure this so-called disease of aging, we have to figure out who designed the flawed system in the first place, right?
We do. And the answer to that, of course, is evolution.
But, evolution isn't some forward-thinking engineer sitting at a drafting table.
Not at all. Evolution is a blind watchmaker. It works exclusively with the environment it's given right in the moment.
Right. So if we look at the evolutionary context of our ancestors, human beings evolved on the Serengeti Plains.
Mm-hmm.
And that environment was basically a nonstop nightmare of hostility.
It was horrific. It was an environment defined by intense, immediate predation, massive famine, tribal warfare, and completely untreatable infectious diseases.
So you weren't worrying about your cholesterol at age 60?
No. The blunt statistical reality for prehistoric humans was that the vast majority were killed by some external force by the time they reached 30 or 40 years old.
Why?
You simply didn't survive long enough for chronic, age-related diseases to even materialize.
So if I'm looking at this purely from the perspective of natural selection, evolution has an enormous blind spot here.
Yes, a massive one.
Because the only thing natural selection actually cares about
Yeah.
is passing your genetic code to the next generation.
Right, survival of the fittest.
So it prioritizes building a body that can grow up really fast, get strong enough to run away from a lion, and breed as quickly as possible.
Exactly. There is zero evolutionary return on investment to build a cellular maintenance system that keeps a human perfectly healthy at age 80.
Because the 80-year-old human didn't exist.
Precisely. This is a concept in biology that's closely related to antagonistic pleiotropy.
Okay, let's unpack that term. Antagonistic pleiotropy.
Basically, it means that the genetic traits that make you wildly successful and fertile at age 20 might be the exact same traits that cause you to develop cancer or heart disease at age 70.
Oh, wow.
But evolution doesn't care about what happens to you at 70 because, historically, you were already dead.
Right.
Once you passed reproductive age and raised your offspring to the point of self-sufficiency, evolution just completely withdrew its protective forces.
The warranty expired.
Exactly. The evolutionary pressure to maintain the organism drops to zero, and the basic forces of physics and entropy just take over. You are biologically discarded.
Okay, I see the logic there, but this raises a massive red flag for me.
What's that?
Well, if our bodies were specifically engineered by millions of years of natural selection to basically expire after 40, because a long life just wasn't useful back then,
Right.
aren't we fighting a completely unwinnable war here? I mean, it feels like trying to run modern, complex software on a computer built in the 1980s. The hardware just isn't designed for it. So aren't we just fighting against our own fundamental biological programming?
It's a very common pushback, and it's a kind of biological fatalism, but it ignores a crucial piece of evidence from the natural world.
Okay, lay it on me.
The biological programming for extreme, centuries-long longevity absolutely does exist, and it's currently running in species all around us.
Wait, really?
Yes. The lifespan of an organism isn't this fixed universal law dictated by biology alone. It is highly elastic, and it's entirely dependent on environmental variables.
So the environment dictates the lifespan potential.
Exactly. Let's look at organisms that lack natural predators. The bristlecone pine tree is a fantastic example from the source material.
Okay.
There are bristlecone pines alive today that literally germinated before the invention of the wheel. They live for nearly 5,000 years.
5,000 years. That completely shatters the idea that biological tissue inherently has to degrade in a few decades.
It does. And if you want an example in the animal kingdom, look at the bowhead whale.
Right. I've heard they live a long time.
They can live for over 200 years. Some have literally been found with antique ivory harpoon tips from the 1800s still lodged in their blubber.
Oh my God, that's insane.
Right. So what do the bristlecone pine and the bowhead whale have in common?
Well, they're both massive.
They live in environments or possess physical defenses that virtually eliminate predation. The pine tree's wood is incredibly dense, and it's filled with this toxic resin, making it completely impervious to insects and rot.
So nothing eats it.
Exactly. And the whale is so massive and lives in such isolated, freezing waters that nothing can hunt it.
Okay, this is a massive light bulb moment for me. Because nobody is trying to kill them every single day,
Uh-huh.
it suddenly makes evolutionary sense for their genetics to invest heavily in long-term bodily repair.
Yes.
You nailed it.
Like, why build a cheap, disposable body if you're actually going to be around for 3 centuries to use it?
Exactly. Their genetics evolved to build highly stable epigenetic control systems, incredibly robust DNA repair mechanisms, and cells that constantly clean themselves out.
Right.
And here is the profound realization for humanity. We are now the whale.
Oh, I love that. We are the whale.
We no longer live on the Serengeti. We have conquered our natural predators.
Yeah, and lions aren't a daily concern for most of us.
Right. They have engineered antibiotics, climate-controlled houses, modern agriculture, sanitation.
He basically took ourselves off the prehistoric menu.
He did. The environmental pressure has drastically changed. Now, if we just waited around for a few 100,000 years, natural selection would likely catch up. Really? Humans would naturally evolve to live longer.
Most likely, yeah. Because those who happen to have slightly better cellular repair mechanisms would live longer, they'd accumulate more resources, and they'd pass those long life genes down.
But we are impatient. We don't want to wait 300,000 years.
Exactly. We don't want to wait for natural selection to give us the biology of the bowhead whale. We want to use science to instantly patch our software to match our newly safe environment right now.
Okay, so we have the safe environment. Now we just need the cellular upgrades, which brings us out of the macro world of evolution and forces us to zoom all the way down into the nucleus of a single human cell.
Right, let's get microscopic.
Because if we want to cure the disease of aging, we have to understand the actual physical mechanics of what is breaking. Like, how does a cell actually get old?
To conceptualize this, the framework uses a really helpful analogy that separates the cell into hardware and software.
Okay, the body is a computer. I like it.
The human body is essentially the most advanced complex computer in the known universe. Your DNA, the famous 3 billion letter double helix of A, C, T, and G that you inherited from your parents.
Right, the genome.
That is the hardware. It is a static physical code. But here is the paradox of biology. The DNA itself does not actually tell a cell what to do.
Wait, what do you mean? I thought DNA was the instruction manual.
It is, but think about this. The DNA in your optic nerve is the exact same DNA that is in your liver, which is the exact same DNA in your skin.
Oh, right. I always forget how wild that is.
It's crazy, right?
Every single cell in your body, from a bone cell to a neuron, carries the complete instruction manual to build an entire human being.
Exactly.
It's like every single worker in a massive factory carrying the blueprints for the entire city, but they only ever build one specific type of door their whole lives.
That is a brilliant way to put it. So if the blueprints are identical everywhere, what makes a cell an optic nerve cell instead of a skin cell?
What tells the worker to only build the door?
Exactly. That is the job of the epigenome. The epigenome is the software of the cell.
Epigenome, okay.
Epi literally translates to above or on top of. So the epigenome sits on top of the DNA hardware, and it uses physical chemical labels to turn certain genes on and silence others.
Okay, let's get really specific about these chemical labels, because this seems to be where the physical reality of aging actually lives.
It is.
How does the cell chemically silence a gene? What's the physical mechanism?
The primary mechanism is something called DNA methylation.
Methylation.
Right. Let's go back to basic high school chemistry for just a second. A methyl group is one of the simplest molecules in the universe. It's literally just one carbon atom with 3 hydrogen atoms attached to it, CH3.
Okay, pretty simple.
Very simple. But the cell takes these tiny methyl groups and physically attaches them to specific parts of the DNA ladder.
Like gluing them on.
Chemically binding them, yeah. Specifically, it attaches them to the cytosine bases, the C's in the ACTG code.
So it's literally sticking chemical traffic cones onto the DNA strands.
That's a perfect image. Traffic cones. When a stretch of DNA is heavily methylated, meaning it's covered in these traffic cones, the cellular machinery that reads the genes physically cannot access that section.
It's blocked.
Yes. The gene is locked away, it's silenced.
Got it.
Now, when you are developing in the room, your cells undergo a massively complex, beautifully choreographed wave of this methylation.
To figure out what they're supposed to be.
Exactly. It tells a specific group of cells, turn off the liver genes, turn off the skin genes, leave only the neuron genes accessible.
So that precise pattern of methyl groups locks the cell into its identity.
Yes. And in youth, this epigenetic software runs flawlessly. The profit cones are exactly where they need to be.
But then
Mm-hmm.
time happens.
Times happen.
And according to this information theory of aging, growing old is not the loss of the DNA hardware. It's a corruption of this delicate software.
That's the core paradigm shift.
Aging is essentially a massive cellular identity crisis.
It is the slow accumulation of epigenetic noise.
Noise, like static.
Exactly. As we live our lives, these methyl labels, these crucial traffic cones, start getting bumped around.
Just from daily life.
From everything. Some traffic cones get knocked off where they're supposed to be, and new ones get randomly dropped where they absolutely shouldn't be.
So the blueprint gets muddy.
Right. Genes that are supposed to be completely silent in a skin cell slowly start to wake up. Genes that are supposed to be active get shut down.
So the skin cell starts looking at a slightly corrupted blueprint, and it starts behaving a little bit like a nerve cell.
Mm-hmm.
And the nerve cell loses some of its instructions and starts behaving a little bit like a liver cell.
Exactly. They literally forget their jobs. The specialized factory workers get amnesia.
That is terrifying, honestly.
And when enough cells in a tissue forget their specific identity, the entire tissue just stops functioning optimally.
So that's the wrinkles.
Yes. The skin loses its elasticity and wrinkles, the organs become sluggish, the immune system misfires. The physical manifestation of old age is simply millions of your cells simultaneously losing their highly specialized identities.
But the DNA itself is fine.
That's the crazy part. Crucially, the genes themselves aren't gone. 99.99% of your DNA code is perfectly intact and pristine even when you are 100 years old.
It's the reader that is broken.
Exactly. It's the reader.
You know, the source material uses this incredible visual analogy that just instantly clicked for me, and I want to share it because it completely reframes how we should picture getting old.
Oh, the vinyl record analogy. It's so good.
Think of your DNA, your perfect youthful genome, as the music pressed into a classic vinyl record.
Right.
All the beautiful, complex symphonies of youth are carved right there in the wax. The epigenome, the methylation patterns we just talked about, is the needle on the record player. It tracks the grooves, reads the music, and plays it back. Aging is not the music disappearing. Aging isn't the wax melting away or the grooves vanishing.
Right. The hardware is fine.
Exactly.
Yeah.
Aging is simply the record getting scratched.
It's the perfect translation of the information theory of aging. When you scratch a vinyl record, the needle jumps out of the groove.
It skips.
Right. It skips beats, it plays the wrong part of the song, or it just produces awful, chaotic static.
And that static is the epigenetic noise.
Yes. That static is the cellular dysfunction, the identity crisis that we associate with biological decline. The cells are desperately trying to read the DNA, but the epigenetic scratches prevent them from reading it cleanly.
And this leads to what I think is the most optimistic, staggering revelation in modern biology.
It gives me chills every time I think about it.
Because if the music is still there underneath the scratches, that means there is a backup copy of our youthful epigenetic information stored deep inside our oldest, most dysfunctional cells.
Yes.
We aren't fundamentally broken. The information hasn't been deleted. We are just playing back corrupted code.
And this is why this is such a paradigm shift. For decades, the entire scientific community viewed aging like a car rusting.
Just simple wear and tear.
Exactly. You can try to slow down the rust, maybe paint over it, but you can't unrust a car. It's a one-way physical degradation.
Right.
But if aging is merely a loss of epigenetic information and a pristine backup copy of that information exists within the cell,
then age reversal suddenly shifts from a biological impossibility to a pure engineering problem.
exactly, you just have to figure out how to access the backup drive. You have to find the reset button.
Okay, so if the scratches on the epigenetic record are causing this massive identity crisis, the immediate question is, what is physically causing the scratches in the first place?
Right. Who is messing with the traffic cone?
Exactly. Why do the methyl groups get knocked around? This brings us to the cellular defense systems, the microscopic bodyguards that are actually in charge of managing this entire process.
We have to introduce a family of highly specialized proteins called sirtuins.
Sirtuins.
You can think of them as the cellular bodyguards, or, to stick with the musical theme, the conductors of the cellular orchestra.
I like the bodyguard analogy.
In mammals, there are 7 of these sirtuin proteins, cleverly named SIRT1 through SIRT7.
Naturally.
In a perfectly youthful, healthy state, these sirtuins have a primary, absolutely vital job. They sit on the DNA, they manage the methylation, and they ensure the cell maintains its precise identity.
So they are the enforcers holding the traffic cones in place.
Yes, they're the ones keeping the needle in the groove.
They are moonlighting.
They are.
They have a second job, and this second job seems to be where the fatal flaw in the system lies.
It is the tragic flaw of our biology. Their second job is emergency DNA repair.
Oh.
Our DNA hardware is under constant, relentless assault. The double helix physically snaps and breaks trillions of times a day across our body.
Wait, hold on. Trillions of times a day. What is breaking it that often?
Literally everything. It breaks naturally just from the mechanics of cells dividing and copying their DNA.
Oh, just normal operation.
Yeah, but it's also constantly shredded by environmental stressors. Background radiation from the Earth.
Like radon.
Sure. Cosmic rays penetrating the atmosphere when you fly in an airplane, UV light from the sun, the chemicals in the food we eat, X-rays at the dentist.
Whoa.
Every single day, the microscopic ladder is snapping all over your body.
So when a chromosome suffers one of these double-strand breaks, what do these sirtuin bodyguards do?
Do panic.
Literally panic.
And rightly so. A severed chromosome is an immediate existential threat to the cell.
Because it could mutate.
Yes. If that broken strand of DNA isn't fused back together almost instantly, the cell will either undergo apoptosis, which is programmed cell death.
Basically cellular suicide.
Right. Or, far worse, it will mutate and become a rapidly dividing cancer cell.
Oh, man. So the stakes are incredibly high.
They are. So the sirtuins drop whatever they are doing. They abandon their primary post at the epigenome, they drop the traffic cones, and they physically rush across the nucleus to the site of the break to coordinate the emergency repair enzymes.
I picture it like a massive game of ping pong inside the nucleus.
That's exactly what it is.
A break happens over here, the sirtuins bounce over to fix it. A break happens over there, they bounce over there.
Yep.
But if they fix the break, shouldn't they just go right back to their original post and pick up the traffic cones? I mean, problem solved, right?
In a perfect world, yes. But biological systems are incredibly messy. After the emergency repair is complete, they don't all find their way back to their original starting positions.
Some of them get lost.
Exactly. Some get lost in the shuffle. Some bind to the wrong part of the DNA.
So the very mechanism designed to save the cell from immediate death is the exact mechanism that slowly degrades the cell's identity over time.
It's a tragic biological trade-off. Over years and decades, with trillions of these daily DNA breaks occurring, you have this constant frantic distraction of the sirtuins.
Bodyguards are constantly running around putting out fires.
And slowly, the epigenetic control of the cell degrades. The methyl labels aren't maintained. The record gets scratched by the needle bouncing around too much.
And that noise is aging.
Yes. This accumulated epigenetic noise, caused by the distraction of the sirtuins, is the physical driver of aging.
Now, in science, a theory is just a nice story until you can prove it in a lab, right?
Absolutely.
And the researchers didn't just guess this ping pong match was happening. They actually designed an experiment to prove it, and it is equal parts elegant and, honestly, absolutely terrifying.
Oh, the ICE mice experiment. It's legendary.
Let's break it down. They engineered what they call the IC mice. ICE stands for inducible changes to the epigenome.
The methodology of this experiment is just a masterpiece of genetic engineering. They needed to prove definitively that DNA breaks and the resulting sirtuin distraction were the direct solitary cause of aging.
Right, because correlation isn't causation.
Exactly. But they had a massive hurdle. Usually when you break DNA with radiation or chemicals, you cause massive mutations that lead to cancer.
Yeah, you can't study aging if the mouse dies of a giant tumor in a month.
Precisely. They needed a way to cut the DNA cleanly without causing any mutations at all.
And to do that, they turned to a forest slime mold, which is just phenomenal to me.
It's amazing.
You have these brilliant Harvard scientists looking at a literal slime mold for the key to human mortality.
Hey, biology relies on the strangest tools. They found a specific enzyme produced by this slime mold called IPPI.
Okay.
This enzyme does exactly one thing. It acts as a highly specific pair of microscopic scissors.
Scissors for DNA.
Right. It cuts DNA, but it leaves the ends perfectly clean, meaning the cell can easily stitch them back together without mutating the code.
That's incredibly convenient.
It really is. So they genetically engineered a group of mice, starting from a single fertilized egg, to include the gene for the slime mold enzyme in every single cell of their bodies.
But they didn't want the scissors cutting all the time, right?
Right.
Otherwise, the mice would just fall apart instantly.
Correct. They needed to control the ping pong match, so they attached the slime mold gene to a chemical switch. Yeah. The scissors would only activate if the mice were fed a specific drug, in this case, a derivative of an anti-estrogen drug called tamoxifen.
Okay, so let me get this straight.
Mm-hmm.
They have a set of identical twin mice.
Mm-hmm.
One group gets normal food. The other group gets the drug in their food to turn the scissors on.
Exactly. For exactly 3 weeks, the slime mold enzyme was activated in the drug group, causing clean cuts across the mice's DNA, forcing the sirtuin bodyguards into a 3-week absolute frenzy of emergency repair.
Just nonstop ping pong.
Non-stop.
And what blows my mind is that during those 3 weeks, if you looked at the mice in their cages, they seemed completely fine.
Right, they were running around normally.
They weren't writhing in pain.
Yeah.
It's the equivalent of us getting a dental x-ray. You don't feel the radiation breaking your DNA.
No, you don't feel a thing.
But on a cellular level, they had set a catastrophic cascade into motion. After 3 weeks, they turned the scissors off, and they just waited.
And they monitored everything. They measured visual acuity, treadmill endurance, memory using complex mazes, hair graying, skin thickness.
All the hallmarks of aging.
Month after month, the epigenetic noise was compounding. The bodyguards had been so thoroughly distracted during those 3 weeks that they couldn't restore the original identity of the cells.
And 10 months later.
10 months later, the results were undeniable. The researchers who bet against this theory lost horribly.
What happened to the mice?
The mice that experienced the DNA cuts aged 50% faster than their genetically identical unedited twins.
50% faster.
Yes. They developed kyphosis, a severely curved spine. Their fur turned stark gray and literally fell out. They went blind. They couldn't navigate the memory mazes anymore.
They became old mice.
They artificially induced every single physical hallmark of deep old age simply by causing DNA breaks and distracting the epigenome.
Wow.
The hardware was perfectly intact, but the software was corrupted. It proved the information theory of aging unequivocally.
It's a watershed moment in biology, honestly.
It definitively proved that the loss of epigenetic information drives the physical decay we call aging.
But, you know, it also holds up a very uncomfortable mirror to our daily lives.
It sure does.
If breaking DNA and distracting sirtuins causes rapid aging, what are we doing every single day that mimics what they did to those mice?
That's the terrifying part. We are constantly taking microscopic scissors to our own DNA.
Right. I mentioned frequent flying earlier.
Yeah. The higher you go in the atmosphere, the less protection you have from cosmic radiation. Pilots and flight attendants actually show accelerated epigenetic aging.
And smoking.
Smoking is essentially inhaling chemical scissors. It violently breaks DNA strands.
Sunbathing.
Spending hours roasting in the sun without UV protection absolutely shreds DNA in your skin cells. Even chronic psychological stress has been shown to shorten telomeres and cause DNA damage.
We're just living in a way that aggressively scratches our own records.
We are.
But this naturally leads to a physiological puzzle for me.
Okay, what is it?
The body evolved this sirtuin system to handle these breaks, right?
Mm-hmm.
When we are 20 years old, we can go to the beach, get a horrible sunburn, repair the DNA, and bounce back pretty quickly.
Right, our bodies fix it.
The sirtuins handle the ping-pong match efficiently when we're young. So why do they fail so catastrophically as we get older? Even if you avoid flying and smoking and the sun, the sirtuins still eventually get sluggish. Why?
It's a great question. If the machines are fully intact, it has to be a problem with the power supply.
The fuel.
Yes. The sirtuins must be running out of fuel. And it turns out there is a very specific, highly regulated fuel source they rely on, a molecule called NAD.
NAD, let's dig into that.
NAD, or nicotinamide adenine dinucleotide, is arguably one of the most important molecules for life on Earth.
That's a big statement.
It is present in every living cell, from simple yeast all the way up to human beings. In biochemistry, NAD is what we call a coenzyme.
Okay, functionally, what does a coenzyme do?
What that means mechanically is that the sirtuin protein is just a dormant, folded-up machine. It literally cannot physically bind to the DNA, it cannot remove methyl groups, and it cannot coordinate repairs until a molecule of NAD slots into it.
Like a key into an ignition.
Exactly like a key. The NAD molecule changes the physical shape of the sirtuin, activating it.
So without NAD, the sirtuins are utterly useless.
Utterly useless. When we are young, our bodies are absolutely swimming in NAD. Our metabolic factories are pumping it out constantly.
So the bodyguards have plenty of energy.
Right. The sirtuins have an unlimited fuel supply, allowing them to bounce back and forth between maintaining the epigenetic traffic cones and fixing the daily DNA breaks with incredible speed and precision.
The grim, inescapable reality of human metabolism is that this fuel supply collapses.
It tanks. By the time we hit 50 years old, our NAD levels have dropped by roughly 50%. Half. Our bodies are producing less of it and actively destroying it faster due to chronic inflammation.
So half the fuel means half the protection.
Exactly. The ping-pong match slows down. The sirtuins take way longer to fix the breaks, and they struggle to find their way back to the epigenome. The identity crisis of the cells accelerates rapidly.
So understanding this biochemical reality that NAD is the critical fuel and its decline drives the epigenetic noise,
Right.
the central question for longevity becomes obvious, right?
Right. How do we get more of it?
Exactly. How do we naturally force our bodies to massively boost NAD production and wake the sirtuins back up?
And this is where we have to transition out of the microscopic world of cellular biology and look at how we actually live our lives on a daily basis.
Because the answer lies in doing the exact opposite of what modern society tells us to do.
It really does. To understand the solution, we have to recognize what researchers call the abundance problem.
The abundance problem. Let's look at the baseline reality of modern life in the developed world. It is completely, totally unnatural compared to the environment we evolved in.
Completely alien.
We wake up in a climate-controlled room set to exactly 70 degrees. We walk to a refrigerator and pull out a massive calorie-dense breakfast that we expended literally zero physical energy to acquire.
You just open a door.
Right. We get into a padded car, drive to a padded chair, and sit completely still for 8 hours. We have air conditioning in the summer, heating in the winter. We end the day lying on a soft couch, watching movies and eating popcorn.
We have successfully engineered a world of absolute, continuous physiological abundance.
Sounds great.
It feels great, but biologically, this abundance is a trap.
Why is comfort a trap?
Because your cellular machinery is constantly monitoring the environment. When you provide it with infinite calories, perfect temperature control, and zero physical exertion, it sends a very specific signal to your DNA.
What's the signal?
It says, everything is perfect, there are no threats whatsoever, survival is completely guaranteed.
And when the body thinks survival is guaranteed, it gets lazy.
Incredibly lazy. The sirtuin defense systems essentially go to sleep, they downregulate. The body stops producing high levels of NAD because it perceives absolutely no reason to expend the energy to maintain maximum defensive readiness.
Why keep the shields up if there are no torpedoes, right?
Exactly. Which means our quest for total comfort is actively accelerating our biological aging. Our cells are decaying faster because they feel zero adversity.
Wow.
So, to hack this biological software, we have to utilize a concept called hormesis.
Hormesis. This seems to be the absolute cornerstone of actionable longevity. How do we define it?
Hormesis translates loosely to the idea that what doesn't kill you makes you stronger, but applied precisely on a cellular metabolic level.
Okay, so a controlled stress.
Yes. It is the biological practice of putting the body into a state of perceived adversity, a controlled state of stress, without actually causing permanent physical damage.
What happens when we do that?
When the cells experience this acute mild stress, they panic. But they panic in a highly productive way.
Productive panic.
Right. The cells think, oh no, a famine is coming, or we are freezing, winter is here, or we are being chased by a predator. In response, the body massively upregulates its survival circuits.
It turns the shields back on.
It pumps out NAD, wakes up the sirtuins, stimulates rapid DNA repair, and turns on recycling systems to clear out cellular garbage.
To really drive home why we need to intentionally inject discomfort into our lives.
Yeah.
Our source material mentions something visceral that Sinclair did during an interview that really stuck with me.
Oh, the lead vest.
Yes. He wanted to demonstrate the physical reality of what failing to maintain your epigenome actually feels like. He brought out a 20-kilogram, about a 45-pound lead vest, the kind they put on you at the dentist.
All right, super heavy.
And a stiff, restrictive medical neck brace.
Yeah.
And he forced the interviewer to put them on.
It is a brilliant, immediate physical translation of biological aging.
The interviewer is sitting there, completely weighed down. He's struggling to take a deep breath because the lead is literally crushing his chest. He can't turn his head to look around the room. He feels this heavy, immovable ache on his joints and his spine. And Sinclair looks at him and says, that is what being 80 years old feels like.
It's sobering.
Old age isn't just a number. It is a heavy, painful, suffocating, immovable suit that slowly locks around your body.
Yeah.
And the absolute realization is that if choosing to be uncomfortable right now, choosing to be hungry or cold or out of breath is the only way to prevent getting trapped in that heavy suit later, we have to lean into the discomfort.
We have to.
So let's break down the mechanics. What is the optimal, scientifically validated way to suffer? How do we actionably apply hormesis?
Well, the most potent, heavily researched method of inducing hormesis is fasting.
Fasting, just not eating.
But not malnutrition, not starvation. Intentionally restricting the time window in which you consume calories.
Right, intermittent fasting.
Yeah, because the modern dogma that we need 3 large meals a day plus snacks and that breakfast is the most important meal of the day is a complete biological fabrication.
It really is, isn't it?
It's largely early 20th century marketing from cereal and bacon companies. Evolutionarily, adult humans were never designed to eat continuously from the moment they wake up to the moment they go to sleep.
So what's the baseline recommendation to activate these survival circuits?
The baseline is to aim for a 14 to 16-hour daily fast.
Okay, so if you finish dinner at 8:00 p.m., you skip breakfast entirely, and you don't eat your first meal until noon the next day.
Exactly. During those morning hours, when your liver is entirely depleted of glycogen and your stomach is empty, your NAD levels begin to spike naturally.
The body thinks there's a famine.
Right. Your sirtuins wake up and start polishing the epigenetic record. But there's an even deeper, much more profound level of cellular cleaning that happens if you push the adversity further.
How far are we talking?
If you want to tap into the deepest metabolic repair pathways, you have to look at extended fasts of about 2.5 to 3 days.
Wow, 3 days with no food.
Water only. When you deprive the body of external calories for that long, you trigger a profound biological process called chaperone-mediated autophagy.
Okay, let's break that down mechanically, because autophagy literally translates to self-eating.
It does.
Which sounds terrible. But it's actually the ultimate anti-aging mechanism.
It is the holy grail of cellular cleanup. Your body fiercely resists going into autophagy because it is a very energy-intensive process.
So how does the process unfold?
When you stop eating, your body first burns through the easily accessible glycogen stored in your liver and muscles.
It's sugar.
Right. Around 16 to 24 hours in, it realizes the sugar is completely gone, so it flips a metabolic switch. It starts breaking down your fat tissue into molecules called ketones.
Which your brain loves.
Your brain absolutely loves ketones for fuel. This is why people on extended fast report incredible mental clarity and focus.
But if you keep pushing past that 48-hour mark,
the body realizes that fat isn't enough. It needs raw materials. It needs amino acids to keep critical systems running. And since you aren't eating protein, it has to find protein from within.
Self-eating.
This is where the cell becomes incredibly intelligent. The cell is basically a bustling city, and over decades, it accumulates a lot of garbage.
Like what kind of garbage?
Misfolded proteins, degraded mitochondria, clumps of toxic biological waste that physically gum up the cellular machinery.
Isn't that what causes dementia?
Yes. This garbage is heavily implicated in diseases like Alzheimer's and Parkinson's.
Wow.
When deep fasting triggers chaperone-mediated autophagy, the cell activates highly specific chaperone proteins. Think of these chaperones as microscopic, highly targeted garbage trucks.
Okay.
They roam the cytoplasm, specifically hunting for misfolded toxic proteins. When they find one, they grab it and drag it to the lysosome.
The lysosome being the cell's stomach, essentially.
Exactly. It's a highly acidic vat of enzymes. The chaperone shoves the toxic protein into the lysosome, where it is violently shredded back into its bis amino acids.
Yeah. And then what?
The cell then recycles those fresh amino acids to build new, healthy structures. It is a profound, deep cellular cleanout, a literal rejuvenation of the cell's interior.
But it only happens when the body is subjected to the severe hormetic stress of prolonged fasting.
Precisely. If you constantly drip feed yourself food every few hours, the garbage trucks stay parked in the garage forever. They never come out.
That is just fascinating. Okay, so beyond fasting, the next major pillar of actionable adversity is physical exercise.
Right.
But again, it's not about taking a leisurely 20-minute stroll on a flat sidewalk.
No, a stroll does not induce panic. The key to triggering the survival circuits is activating the hypoxic stress response.
Hypoxic, meaning low oxygen.
Hypoxia simply means a lack of oxygen. When you exercise at a high intensity, your muscles rapidly consume oxygen faster than your lungs, and heart can deliver it.
You get winded.
Yes. Your cells literally sense this oxygen depletion. It's a massive chemical stressor.
What happens then?
A biological pathway known as AMPK, senses the low energy state, and immediately signals the body to synthesize massive amounts of NAD
To fuel the sirtuins.
to protect the DNA from the perceived impending damage of physical exhaustion. Yeah.
So the metric for success isn't just how many steps you took on your Fitbit, it's your respiratory rate.
Exactly. You need to push your cardiovascular system to the point where you literally lose your breath.
You need to exercise at an intensity where you physically cannot carry on a conversation, and you need to hold that state for at least 5 minutes, roughly 3 times a week.
That acute, intense lack of oxygen is the alarm bell that wakes the sirtuins up.
Okay, so fasting, intense exercise. What's the third pillar?
The third pillar of hormesis is temperature stress.
Hot and cold.
Right. We spend our lives in a perfectly stable 70-degree bubble. By intentionally subjecting ourselves to extreme heat or extreme cold, we shock the system.
Cold plunges are huge right now.
They are. And cold plunges force the body to rapidly generate brown fat to burn energy for heat. But the data on heat stress, particularly saunas, is incredibly robust.
Yes, Sinclair heavily advocates for sauna use in the sources. And the proposed mechanism here revolves around something called heat shock proteins.
Let me explain how that works. When you sit in a deeply hot environment, say a traditional dry sauna at 180 degrees Fahrenheit, your body's core temperature begins to rise.
Obviously.
On a cellular level, extreme heat causes proteins to physically unfold and lose their shape, which is fatal to the cell.
You're cooking them.
Literally. So as the temperature climbs, the cells panic and rapidly deploy heat shock proteins.
What do?
These proteins act like tiny scaffolds. They bind to the cellular structures to physically prevent them from warping and melting.
That's amazing.
At the same time, this thermal stress triggers a massive release of cardiovascular nitric oxide, which forcefully expands the blood vessels.
Does this translate to real-world longevity?
Absolutely. Extensive epidemiological studies on men in Finland, where daily, intense sauna use is culturally ingrained, show profound, massive reductions in fatal cardiovascular events and all-cause mortality.
So the overarching theme of these physical lifestyle interventions is cyclical stress.
Cyclical is the key word.
You don't want to be starved, freezing, and exhausted 24/7. That's just destructive trauma.
Right, that will kill you.
You want to pulse the body. You spike the stress. You let the body panic. You let the NAD flood the system and sirtuins polish the epigenome, and then you recover.
You constantly remind the biological software that survival requires effort.
I love that phrase. But, we can't fast and sit in the sauna forever.
We do.
Eventually, we do have to eat.
We do.
And the biochemical reality of what we eat is just as critical as when we eat, because specific foods apparently have the astonishing ability to chemically mimic the adversity our bodies desperately need.
Yes, diet is a huge component of this.
This brings us to a really fascinating, highly debated area: diet. When we talk about anti-aging diets, one of the most popular, inescapable trends right now is the keto diet.
Right, everyone is talking about keto.
The interviewer in the source material actually presses Sinclair on this, noting that when he enters cyclical ketosis, eating extremely high fat, moderate protein, and virtually zero carbohydrates, he feels this immense mental clarity.
And that's true, ketones do that.
He feels focused and articulate. It's a hugely popular biohacking trend. So, based strictly on the longevity research, what is the mechanistic verdict on keto?
Well, it requires a nuanced understanding of short-term versus long-term biology.
Right.
Short-term, a ketogenic diet is highly effective for rapid weight loss, stabilizing blood sugar, and generating those ketones that the brain loves. It does mimic some aspects of fasting.
But long-term?
Long-term, from the perspective of maximum lifespan extension, a heavy meat and dairy-based ketogenic diet that lacks complex plant material is detrimental.
Really? Why is that?
Because the vast majority of biological evidence, including the diets of the longest-living human populations in the blue zones, heavily favors a lean, predominantly plant-focused diet.
And the reason for this isn't just the standard vegetables have vitamins and fiber argument, is it?
No, it relies on one of the most mind-blowing biological concepts I've ever encountered. It's called xenohormesis.
Xenohormesis, let's define that.
Xeno meaning foreign, and hormesis meaning beneficial stress. Xenohormesis is the evolutionary theory that animals, including humans, have evolved the ability to benefit from the stress of other living organisms.
Specifically plants.
Yes.
Let's unpack the mechanism of this because it's brilliant. Think about a plant in nature, an olive tree or a grapevine. If a plant is subjected to severe stress, If there's a horrible drought and it's not getting enough water, or if it's getting blasted by harsh, damaging UV sunlight, or if an insect starts eating its leaves, the plant has a massive problem.
A huge problem. It cannot uproot itself and run away.
Exactly. It has to sit there and fight for its life using chemistry.
Right. So when a plant is stressed, it produces incredibly potent, complex chemical defense molecules called polyphenols.
Polyphenols.
Resveratrol, which is famous for being in red wine, is a polyphenol. Quercetin, found in apples and onions, is another. There are hundreds of thousands of them in nature.
So they are plant armor.
Yes, these molecules are the plant's biochemical survival mechanism. They act as antioxidants, antifungals, and cellular protectants for the plant itself.
And here is the magic evolutionary hack. When we eat those stressed plants, we ingest those chemical defense molecules.
We do.
And over millions of years of evolution, our bodies and the bodies of the animals we evolved from learned to recognize these specific plant chemicals.
They act as messengers.
Right.
When our cells detect these polyphenols floating in our bloodstream, it acts as a massive systemic alarm bell.
What does the cell think is happening?
Our cells sense the plant stress molecules and they infer the state of the environment. The cellular logic is, if the plants we are eating are highly stressed, that means the environment around us must be turning hostile.
A drought is happening. The food supply is collapsing.
We need to prepare for the worst. So, simply by detecting the xenohormetic signal from the plant, our cells massively upregulate our own internal sirtuin defenses.
Even if we were just sitting comfortably on a couch eating a salad.
Exactly. You essentially get the cellular epigenetic benefits of fasting and intense exercise just by eating the correct chemical signals.
That feels like a cheat code.
It is a biological cheat code. Sinclair uses a fantastic analogy to explain how these polyphenols interact with the NAD fuel we talked about earlier.
The gas pedal analogy.
Right. If NAD is the gasoline in the tank, the actual physical fuel for the sirtuin engines, then polyphenols act as the accelerator pedal.
Oh.
You absolutely need the NAD gas to make the engine run, but the polyphenols step on the gas, pushing the sirtuin enzymes to their absolute maximum performance level.
So, practically speaking, how do we build a diet around xenohormesis? Sinclair advocates for a longevity diet that focuses on eating the rainbow, right?
Yes, choosing intensely colored, heavily stressed plant foods packed with these accelerator molecules.
Let's break down the all-stars of this diet. First on the list, matcha green tea. But not just any green tea.
No, traditional Japanese matcha is a masterclass in intentional xenohormesis. The growers don't just let the tea leaves grow naturally in the sun.
What do they do?
For weeks before the harvest, they physically cover the entire tea plantation with massive shade cloths, blocking out the sun.
Oh, to stress the plant.
Yes. This sudden, severe deprivation of light brutally stresses the plant. It literally thinks it's dying.
Wow.
In a desperate attempt to capture any remaining photons, it massively overproduces chlorophyll, which is what gives high-quality matcha its vibrant neon green color.
Okay.
But simultaneously, it pumps out huge, concentrated amounts of protective polyphenols, specifically one called EGCG.
So when you drink it...
When you drink unsweetened, high-quality matcha, you're drinking a highly concentrated liquid dose of pure plant adversity.
That's incredible. Another massive player on this list, Brussels sprouts.
Yeah.
I know they are the classic childhood nightmare vegetable. They have that very distinct, somewhat bitter, sulfurous smell when you cook them.
But that smell is the smell of longevity.
Oh, really?
It comes from a heavily researched molecule called sulforaphane, which is abundant in cruciferous vegetables like broccoli and Brussels sprouts.
What does sulforaphane do?
Sulforaphane is a remarkably potent chemical signal. When it enters your cells, it physically binds to a repressor protein, which frees up a master regulatory pathway called NRF2.
NRF2.
When NRF2 enters the nucleus, it turns on a massive array of antioxidant and detoxification genes, kicking our cellular defenses into high gear.
You also have the deep, dark purple and blue foods. Blueberries, blackberries.
Yes, the dark pigments in the skins of those fruits are called anthocyanins, and those pigments are the polyphenols.
And to absorb all of these molecules, you have to combine them with healthy fats, right?
Correct. Many polyphenols are fat-soluble. Avocados are fantastic, but the ultimate longevity fat is extra virgin olive oil.
Why olive oil specifically?
High-quality olive oil contains specific fats, particularly omega-9 fatty acids, which studies have shown can independently activate the sirtuin enzyme.
Oh, that's great.
But if you get a really robust, peppery olive oil, the kind that slightly burns the back of your throat when you swallow it.
Yeah, I know that burn.
That burn is the physical sensation of the polyphenols, particularly one called oleocanthal. And again, you want olive oil that comes from stressed trees growing in harsh, dry climates because those trees produce the most polyphenols.
Okay, this naturally leads to an incredibly uncomfortable biological truth for the hardcore carnivores and the keto purists out there.
It does.
If I want to optimize my sirtuins, why can't I just eat a giant ribeye steak? Why not meat?
It comes down to fundamental biology. Animals do not synthesize polyphenols.
Right.
A cow cannot produce resveratrol or sulforaphane. If your diet is exclusively or extremely meat-heavy, you are effectively starving your body of these essential age-delaying environmental signals.
Your sirtuins have the NAD fuel, but nobody is pressing the accelerator pedal. And there is a secondary, highly destructive mechanism involved with eating massive amounts of meat. We have to talk about the MTR pathway.
MTR is crucial here.
MTR stands for the mechanistic target of rapamycin. It is another ancient nutrient-sensing pathway in our cells.
Right. Where sirtuins react to NAD and stress, MTR reacts specifically to the presence of amino acids, particularly leucine, which is highly concentrated in animal meat and dairy.
Okay, so when you eat a big steak, your bloodstream floods with amino acids.
The MTR pathway senses this massive influx of building blocks and it turns on. When MTR is active, it sends a powerful signal to the cell. Times are great, we have infinite resources, build, grow, divide, multiply.
Which sounds great if you're a 20-year-old bodybuilder trying to put on muscle.
Exactly, it's an anabolic state. But if you are trying to maximize longevity and prevent aging, a constantly stimulated MTR pathway is disastrous.
Why is building disastrous for longevity?
Because when the cell is obsessively focused on building and growing, it completely shuts down the repair and recycling systems.
Whoa.
It shuts off that deep cellular cleaning, the chaperone-mediated autophagy that we discussed earlier. The garbage trucks stay parked.
So you're building new stuff on top of garbage.
Yes. For maximum longevity, you want MTR downregulated and silenced as frequently as possible, which a plant-heavy, fasting-mimicking diet accomplishes.
You only want to spike MTR occasionally to maintain muscle mass, not constantly stimulate it with 3 meat-heavy meals a day.
That's the balance.
Okay, so let's summarize the defensive baseline here. We know we need to constantly induce adversity. We need to fast to turn on the garbage trucks. We need to induce hypoxia with intense exercise. We need thermal stress. And we need to eat stressed plants to chemically press the sirtuin accelerator pedal.
That's the lifestyle prescription.
If we do all of this perfectly, we can radically slow down the scratching of the epigenetic record. We can stall the aging process and extend our health span remarkably.
But slowing down the damage is still just playing defense.
Right. Lifestyle and diet can only delay the inevitable.
To cure the disease, to actually polish the scratches completely out of the record, to physically reverse the damage and make an old, failing organ fundamentally young again, we have to cross a massive threshold.
We have to look to the cutting edge of gene therapy.
Yes. We are transitioning now from the realm of natural prevention to the awe-inspiring, almost unbelievable reality of medical age reversal.
This is where my jaw literally hit the floor reading the research. We aren't talking about theory anymore.
No, this is applied science.
The Sinclair lab has published groundbreaking work showing that they have successfully cured complex blindness in advanced age mice and subsequently in non-human primates.
By fundamentally reversing the biological age of the optic nerve.
That is just nuts. They took mice that had completely lost their vision due to age-related glaucoma and optic nerve damage. Their nerve cells were completely crushed and biologically exhausted, and they turned back the clock.
The interviewer in the source material pushes Sinclair for the exact mechanical breakdown of how they achieved this, and I want to do the exact same thing right now.
Yeah, let's get into the weeds. It is probably the most important medical procedure of the 21st century.
I agree.
How do you physically deliver an anti-aging software update to a living human eye? It sounds like a plot device from a sci-fi movie.
It relies on a masterpiece of bioengineering, specifically a highly sophisticated delivery mechanism. To get new instructions into a living cell, researchers use a hollowed-out, completely harmless virus.
Right?
Yes. In this case, an adeno-associated virus, or AAV2. Think of this virus as an empty, microscopic FedEx truck.
Okay.
Or, as Sinclair describes it, a tiny viral soccer ball. Because it is a virus, its natural evolutionary ability is to perfectly penetrate the membrane of a human cell.
It's a natural syringe.
Exactly. But if you inject a virus into the body, you don't want it randomly infecting heart cells or liver cells if you're actively trying to fix the eye. You need it highly targeted.
Right. You want the FedEx truck to go to the right address.
So the bioengineers modify the physical surface proteins of this viral soccer ball. These capsid proteins act as a highly specific biological zip code.
Oh, that's clever. They mathematically ensure that when trillions of these microscopic FedEx trucks are injected into the fluid of the eye, they only recognize, dock with, and penetrate the specific optic nerve cells at the back of the retina.
They bounce harmlessly off of everything else.
Correct.
Okay, so the FedEx truck finds the exact right house. It docks, it opens up, and what is the package it drops off inside the nerve cell?
It delivers a tiny, artificially engineered loop of DNA containing 3 specific youth-restoring genes.
3 genes.
These genes are known as the Yamanaka factors, specifically OCT4, SOX2, and KLF4.
What are they?
These are highly powerful genes that are typically only active when we are developing embryos in the womb.
Embryonic genes.
When these genes are turned on in an adult cell, they act like aggressive scrubbers. They sweep across the epigenome, chemically ripping off the accumulated methyl scratches and flawlessly restoring the pristine, youthful methylation pattern.
But here is where the engineering gets insanely tricky, right? You can't just drop those genes in, turn them on, and walk away. No, absolutely not. If you scrub the epigenetic record too hard, the cell forgets that it's an optic nerve entirely.
It loses all identity.
Right, it reverts all the way back to a blank 0-year-old stem cell.
And if you create a mass of rapidly dividing, identityless stem cells in the back of the eye, you haven't cured blindness. You've just created a massive tumor.
A teratoma, exactly. Finding the boundary was the hardest part. They had to find the biological Goldilocks zone.
Not too little, not too much.
You want to take an 80-year-old nerve cell and scrub it just enough to take it back to being a healthy 20-year-old nerve cell, but stop before it becomes a 0-year-old stem cell.
So how do you mathematically stop the scrubbing at exactly the right moment?
This is the genius of the system. They engineered a chemical safety switch into the DNA loop. It's called a TEDON system.
A switch?
Yes, the 3 youth genes are packaged with a repressor protein that physically blocks them from being read.
So they're turned off by default.
The genes lay completely dormant inside the patient's cells indefinitely. They do nothing until the patient takes an incredibly common, cheap, over-the-counter antibiotic called doxycycline.
Doxycycline, like for acne or Lyme disease.
Exactly the same stuff. The doxycycline molecule physically binds to the repressor protein, altering its shape and pulling it off the DNA. Doxycycline acts as the precise chemical trigger.
The mechanics of this are unbelievable.
It's beautiful engineering.
The patient takes the doxycycline pill, the antibiotic enters the bloodstream, hits the eye, the repressor lifts, and the switch flips.
Right.
For exactly 6 to 8 weeks, while the patient takes the pill, the 3 youth genes turn on. The cell's internal clock spins backward.
The epigenetic scratches are systematically polished out.
The nerve cells regain their youthful identity, they regenerate their severed connections, and they suddenly remember how to fire and communicate with the brain. The blindness is cured.
The biological age of the cells is objectively reversed by roughly 75%.
And then the patient just stops taking the antibiotic pill.
The doxycycline leaves the system, the repressor binds back to the DNA, the switch flips off, and the cells safely lock into their newly rejuvenated 20-year-old state.
No tumors. Just perfect vision.
It is a profound, undeniable proof of concept. And Sinclair stresses that reversing blindness is merely the first application.
Right, because if it works in the eye.
The human clinical trials for this exact AAV2 optic nerve therapy, targeting devastating conditions like severe glaucoma and sudden optic strokes, are imminent.
But the true weight of this discovery is that if this system proves safe and effective in the enclosed, observable system of the human eye, the fundamental technology is universally scalable.
Universally. By merely swapping out the surface proteins on the viral FedEx truck, by changing the biological zip code, you could send those exact same 3 rejuvenating genes with the exact same doxycycline switch to any organ in the body.
You could send them to the liver to reverse cirrhosis and fatty liver disease.
Yes.
You could send them to the heart to reverse cardiovascular stiffening. You could send them to the brain to scrub the epigenetic noise causing dementia and Alzheimer's.
The implications for treating diseases that we currently consider terminal or inherently untreatable are simply staggering.
Take cancer, for instance.
Yes, cancer is a huge one. The prevailing view of cancer is that it is primarily driven by genetic mutations, hardware damage.
Right, broken DNA.
But Sinclair's lab views cancer fundamentally as the ultimate cellular identity crisis.
Because if a cell completely loses its epigenetic traffic cones, it forgets it's a specialized tissue cell and reverts to a primal state where its only instruction is to aggressively divide and conquer.
Exactly. A cancer cell is a cell with profound epigenetic amnesia.
So what happens if you apply this therapy?
In the lab, researchers have experimented with applying this precise age reversal technology to aggressive cancer cells. The theory is, if you rejuvenate the cancer cell's epigenome, you force it to wake up and remember its healthy original identity from decades ago.
And what are they seeing in the petri dish?
It is astounding. When the cancer cell's epigenetic software is rebooted, it remembers it is supposed to be a normal, regulated tissue cell. It stops dividing frantically.
It just stops.
And in many cases, once the youthful software is running perfectly again, the cell suddenly recognizes its own catastrophic hardware mutations and immediately undergoes apoptosis.
It cleanly and safely kills itself.
Yes.
You were talking about reversing the age of a tumor to cure cancer. It completely flips the entire cut, burn, and poison paradigm of modern oncology on its head.
It's a completely new way of viewing disease.
And this rejuvenation isn't just about fighting disease. It's about restoring fundamental biological functions that we thought were permanently lost to time. Let's talk about the frontier of reproductive longevity.
This was a massive shock to the scientific community.
We have always been taught a very strict biological dogma. Female mammals are born with a finite, predetermined number of eggs. When they are gone, the ovaries fail, menopause hits, and the reproductive window closes permanently.
That's what's in every textbook.
But Sinclair's lab experiments completely shattered that textbook dogma.
They did. They took female mice that were 16 months old, which in mouse years is roughly equivalent to a 65 or 70-year-old human female.
Okay, so deeply postmenopausal.
Completely infertile for months. Their reproductive organs were biologically exhausted.
What do they do?
The researchers applied the AAV gene therapy, targeted specifically with the zip code for ovarian tissue, and flipped the doxycycline switch.
And the result wasn't just slightly healthier tissue. It wasn't just a delay of menopause.
No. The ovaries fundamentally rejuvenated. The epigenetic clock spun backward, and the ovaries actually began producing completely pristine, healthy, new eggs.
Wait, really? New eggs?
Yes. These highly advanced age 70-year-old equivalent mice were able to conceive normally and give birth to completely healthy litters of offspring that went on to live normal lifespans.
The biological clock was not just slowed, it was completely rewound.
If this technology translates safely to humans, and the fundamental biology strongly suggests it fundamentally alters the entire timeline of human existence.
It changes family planning, it changes economics, it changes the structure of careers and society.
And that brings us to the inevitable macro-level discussion.
Yeah, we have to go there. If this technology succeeds, and a safe, affordable viral injection can scrub the scratches off our epigenetic records, whenever we feel like we are slowing down, it will fracture the fundamental timeline of human existence.
We have to shift from the microscopic mechanics of the nucleus to the macro-societal and philosophical implications of a species that suddenly controls its own mortality.
Because this isn't just a medical breakthrough. This is a philosophical earthquake. It challenges everything we believe about the human experience.
It really does. The interviewer in the discussion pushes back with a really deep existential concern, and it's one that I think a lot of people feel instinctively when they hear about living to 150. If we can live forever, or at least for multiple centuries with the bodies of 30-year-olds, don't we lose our fundamental sense of urgency?
Doesn't the profound, terrifying scarcity of time give life its actual value?
If you know a beautiful sunset is going to happen every single day for the next 1,000 years, do you even bother looking at it anymore?
It's the classic existential fear of infinite boredom. The argument that death gives life meaning.
But Sinclair counters this by challenging our valuation of youth and health itself.
Right. He returns to the analogy we started with.
He asks, would you, as a healthy, vibrant 33-year-old, voluntarily trade places with an 80-year-old billionaire?
Would you accept infinite wealth if it meant instantly and permanently inhabiting an achy, frail, mobility-restricted, cognitively declining body.
Absolutely not. There is no amount of money on Earth that is worth surrendering the physical capacity to effortlessly engage with life.
Exactly. Youth, mobility, cognitive sharpness, and health are inherently, intrinsically valuable states of being.
They don't lose their value simply because you have more of them. Why would extending a state of profound well-being make that well-being less valuable?
If you love playing the piano, you don't stop loving it just because you have 100 years to practice instead of 20.
That's a great point. And beyond the philosophical defense, the economic argument for age reversal is mathematically undeniable.
Oh, the economics are insane. The primary catastrophic burden that is currently bankrupting modern global healthcare systems is the sick years.
Yes, the last decade of life where individuals require intense, chronic, incredibly expensive palliative care simply to manage their slow decline.
If you utilize gene therapy to compress the morbidity, if you drastically extend the healthy, highly functional, productive years, you aren't just saving lives. You are unlocking massive, unprecedented economic productivity.
You eliminate the trillion-dollar drain of chronic aged care entirely.
People could effortlessly have 3 entirely different 40-year careers.
We could build deep, incredibly stable, multi-generational family structures where great-great-grandparents are actively playing soccer with their descendants.
We would benefit from the accumulated wisdom and emotional intelligence of a 100-year-old housed in the energetic, tireless body of a 30-year-old.
The compounding intellectual capital would push humanity into a new renaissance.
But the conversation takes a turn near the end of the sources that goes even further down the rabbit hole.
Oh, it gets wild.
It guides us into some truly abstract, almost terrifying terrain. If we're on the verge of extending our biological consciousness for centuries, we eventually have to grapple with the ultimate question. What exactly is consciousness, and what is this reality we're actually experiencing?
And this is where Sinclair, a geneticist, suddenly starts sounding like a theoretical physicist.
They bring up quantum mechanics to illustrate how deeply strange and unresolved our physical reality actually is.
Specifically, they dive into the implications of the double-slit experiment.
Okay, we have to break the double-slit experiment down mechanically for the listener, because it is the most mind-bending, reality-breaking concept in all of science.
It really is. It proves that the universe does not behave the way we think it does.
Let's set the stage. Imagine a physical setup in a lab. You have a gun that fires tiny, single particles of matter, like individual electrons. In front of the gun, you place a solid barrier with 2 vertical slits cut into it. And behind the barrier, you have a phosphor screen that detects where the electrons hit and leaves a glowing mark.
So far, so simple.
If electrons were just tiny, solid baseballs, you would expect them to fire through the 2 slits and leave 2 distinct vertical bands of hits on the back screen.
Exactly. That's classical physics. You throw a ball through a window, it hits the wall behind the window.
But that is not what happens.
No, it is not.
When you fire the electrons through the slits, they don't form 2 bands. They form an interference pattern, a complex series of many alternating bright and dark stripes spread across the entire back wall.
And the only way an interference pattern can be created is if waves are crashing into each other.
Like dropping 2 pebbles in a pond and watching the ripples interact.
Right. Which means the single solid electron behaves like a wave of probability. As it approaches the barrier, it seemingly exists in multiple places at once.
It goes through the left slit, it goes through the right slit, it goes through both slits simultaneously, and it goes through neither slit.
It interferes with itself and creates the wave pattern on the back wall. It exists purely as a cloud of mathematical probability.
But, and this is the part that literally breaks your brain and keeps physicists awake at night, the scientists wanted to know which slit the electron was actually going through.
Naturally.
So they placed a highly sensitive microscopic detector right at the slits to actively watch the particle as it passed.
And the moment they did that, the entire universe changed its behavior.
The mere act of placing the detector, the mere act of conscious observation, caused the wave function to collapse.
The electron stopped behaving like a wave of probability. It suddenly behaved like a solid, classical baseball.
It went through exactly 1 slit, and it formed 2 simple, clean lines on the back wall.
I want to make sure everyone understands the gravity of this.
Yeah, please.
The physical universe behaves completely differently depending on whether or not a conscious mind, or a tool of a conscious mind, is observing it.
When we aren't looking, matter's just a blur of probabilities. When we observe it, It snaps into solid reality.
This is the Copenhagen interpretation of quantum mechanics, and it leads to a profound, almost unsettling philosophical conclusion.
What does it imply?
It suggests that reality itself might be actively generated by our conscious observation of it.
It lends serious mathematical credence to simulation theory, the idea that the universe only renders the graphics of reality when a player is actively looking at them, just like a video game engine saving processing power.
So, if conscious observation is the fundamental mechanism that forces the chaotic universe to materialize from a blur of probability into solid, structured reality, then consciousness isn't just an accidental byproduct of biology.
It is the core operating system of the cosmos.
And if that is true, then curing aging, preserving the biological hardware, and extending consciousness isn't just a selfish medical goal to avoid death.
It might be the ultimate functional goal of the universe itself.
The universe requires conscious observers to exist in a defined state, and we are the vessels of that observation.
Wow. Let's try to synthesize this incredible journey we've been on today.
It's been a lot to process.
We started by completely shattering the illusion that aging is a natural, inevitable decline. We redefined it as an information loss. A beautiful vinyl record getting tragically scratched by the very sirtuin bodyguards trying to protect it.
We explored how our biology evolved to survive the brutal short-term horrors of the Serengeti, and how our modern world of perfect temperature control and endless calories is inadvertently putting our cellular defenses to sleep.
We learned that we can actively hack our biology by inducing adversity. We can trigger chaperone-mediated autophagy by fasting. We can spike our NAD levels by sprinting until we lose our breath.
And we can utilize xenohormesis by drinking matcha and eating stressed plants to chemically floor the sirtuin accelerator pedal.
And finally, we move past daily lifestyle interventions into the breathtaking frontier of medical science, unpacking how AAV2 viral packages will soon deliver youth-restoring Yamanaka genes directly into our cells.
Rewinding the epigenetic clock and curing diseases from blindness to cancer, all controlled by a simple antibiotic switch.
As you go about your day today, I heavily encourage you to evaluate your own daily routine. Where is the adversity in your life?
Are you living in a state of total, uninterrupted abundance, letting your sirtuins fall asleep at the wheel?
Are you constantly scratching your own epigenetic record with chronic stress, lack of sleep, and highly processed food? Or are you utilizing hormesis to actively defend your cellular identity?
And as we close, I want to leave you with one final, lingering thought based on the exact mechanics of the gene therapy we discussed.
Right.
When those viral FedEx trucks deliver that loop of DNA into a patient's optic nerve, that new DNA stays there permanently.
It integrates and becomes a permanent fixture of their cellular makeup.
This means that every single patient receiving these age-reversing treatments is technically fundamentally becoming a transgenic human.
They're walking around carrying artificially engineered synthetic genetic material.
Yes.
As this technology inevitably succeeds in clinical trials, scales up and democratizes over the next few decades, we are going to be faced with a profound species-level question.
In the 22nd century, will the very definition of a normal human being inherently include carrying artificially engineered, viral-delivered genetic backup drives?
Will our great-grandchildren, living vibrant lives at 150 years old, look back at our pure, unedited, natural human DNA, not as something sacred to be preserved, but as a dangerously fragile, unpatched operating system?
Will they view unedited humanity as an obsolete version of our species that tragically accepted disease, frailty, and a terrifyingly short lifespan simply because they hadn't invented the software update yet?
It is certainly something to chew on the next time you look in the mirror, see a new gray hair or a new wrinkle, and wonder if that visible scratch on the record is truly your inevitable fate, or if it is just a diagnostic muddy water, desperately waiting for the right software patch to clear it up.